As you probably know, we use Ludo pieces in this video series to illustrate how to route incoming calls in contact centers to agents who'll help the callers. As I say at the beginning of all videos in this series, contact centers are busy places. So when you call a contact center, you very often end up in a queue while you wait for an agent to become available to help you. Many organizations have more than one queue. In fact, it's quite common to have multiple queues. When that's the case, agents often work on several queues at a time. This way the organization can get the most out of their agents. It would be a waste of resources, after all, if some agents just sat idle waiting for calls to come in on a queue that's rarely used. And now over to waiting. This door stopper is pretty heavy. This roll of sellotape is lighter and this paperclip is very light. Imagine that those queues each have a weight. This purple queue will weigh in with this much weight and get a high priority. This queue will weigh in with this much weight and get a slightly lower priority. And this queue will weigh in with only this much weight and get a pretty, very, very low priority. So, the scenario for this video is that we have an agent called Helen, who works on all three queues. She monitors the three queues, so to speak. All three queues have callers waiting. So which queue will Helen get her next call from? Well, by default, she'll get the call that has waited the longest. That's a core principle in assigning solution. You can also use something called queue priorities, like illustrated in one of the other videos. If that's the case, that can determine which queue she'll get her next call from. But in this case, we'll look at how long calls have waited in the queues and then multiply those waiting times by a certain weighting for each queue. That's what we're going to look at now. Here you have the three queues that Helen works on. The white queue has a waiting of 2. The call that's first in line has waited for 2 minutes. Now 2 times 2 is 4, so that call there will get a score of 4. The grey queue has a waiting of 4. The call that's first in line has waited for 1 1/4 minutes. 2 times 1 1/4 is 5, so that call scores 5. The purple queue has a waiting of 6. The call that's first in line has waited for, well, only 1 minute. But 6 times 1 is 6, so that call gets a score of 6. So in this example, the call from the white queue has waited the longest, that is 2 minutes. But because of the queue weightings, the Zylinc system will send the call from the purple queue to Helen because that call has the highest score, a score of 6, despite the fact that it hasn't waited as long as the other calls who are first in line in their respective queues. By the way, if you use a queue weighting, like we did in this example, calls from queues with no weight are always served last, regardless of waiting time.